Every time you type something into ChatGPT, the very first thing it does before it writes a single word back is figure out what you mean. Not just the words, the meaning behind them. Here's the question. The bat flew out of the cave at night. What kind of bat? The animal or a baseball bat that someone threw? You figured it out instantly. The AI does too. But the AI doesn't speak English, it only understands numbers. So, how does it turn your words into something it can work with? Well, let me show you.
Keep houseofthings.com open in another tab. You will want to play with this as we go along. Please find the link in description.
This is how AI sees language. Every single dot in this cloud is a word, 10,000 of them to be exact, positioned by a real AI model. When you learn a language, your brain builds invisible connections. Happy connects to glad and joyful. Cat connects to dog and pet. And AI does the same thing, except it stores those connections as lists of numbers called embeddings. During training, the model reads billions of sentences and notices which words show up in similar situations. Words that appear in the same kinds of sentences get similar numbers. That's how the model figures out what that king and queen are related without anyone telling it. Each word's numbers form a position in space, like how lat long place a city on a map. Except instead of two numbers, this model uses 384. We can't visualize 384 dimensions, so the tool crunches them down to 3D. So you can spin it around and explore. Now, let me search something. See these lines that shoot from the center towards king and its neighbors? Well, look at the side panel. The words closest to king, kingdom, queen, prince. Nobody programmed that. Nobody wrote a rule saying kings relate to queens. The model figured it out purely from pattern text because king and queen show up in same kinds of sentences. See these numbers? The first one is a similarity score, in which 1 means identical meaning or the same position. 0 means totally unrelated. Queen is getting 0.68. Prince is getting 0.588. The number in degrees is the angle between the two word positions or the two vectors that you see drawn here. Smaller angles mean closer meaning. Now, let me try something more ambiguous. Bat. Look at its neighbors. Baseball, batteries, Batman. Cricket, hitting, softball. The word bat has a lot of different contextual meanings. It also forms the core of a lot of other words. So it comes close to a lot of very unrelated words. But the model has captured all of its meaning. But here's the problem. Bat always sits in the same spot. In this view, no matter which meaning you intend, when you hear the bat flew out of the cave, you instantly know it's the animal. How does the AI do the same? Well, that's where the context comes in. Let me scroll down to the next tool. This tool shows what happens when you put a word in a sentence. The previous tool showed where words sit by themselves, their default position. This one shows how surrounding words or neighboring words in a sentence pull on each other's meaning. Let's see what bat. Look at the cloud now. Well, here's where bat is. The gold dots are where each word sits by itself, its default position. The red dot is where it moved after it drew on context. The model moved each word after reading the full sentence. The gap between the gold and the red, that's the context shift. The side panel shows two things. First, this bar chart. It shows which words in the sentence influence the bat most. See, so cave, night, flew. These are the words that model paid the most attention to when figuring out what bat means here. This is literally the attention mechanism, the same one inside ChatGPT. The model looks at every word and decides how much should this word influence the meaning of bat. When I click on the context alone, these are the neighbors when bat is by itself, a mix of everything. Baseball, batteries, Batman, battery, right? The model doesn't know which meaning you want, so it gives you both. But when I click on in context, completely different neighbors. cave, night, Batman, battery. See that insight line at the bottom? Context shifts meaning towards cave and night, not baseball and bat. And in the 3D cloud, the red dot is where bat ended up. The green lines go to the new neighbors. It physically moved through the space towards the animal cluster. Now, let me try the same word in a completely different sentence. Well, here, ball influenced the most, grabbed influenced the most. The word standalone was again the same thing, baseball, batteries, bat, but in context, it moved towards hitting baseball ball, more object context. The same three-letter word, but the surrounding words pulled it in the opposite direction. This is how LLM resolves ambiguity. Every word starts at a default position, then the model reads the surrounding words, figures out how much each one matters using attention, and shifts the words position towards the right meaning. Your brain does the same thing, but it's so fast you don't even notice. The AI does it with matrix multiplication and an insane amount of math again and again. So, in conclusion, words become numbers. Those numbers form position space. Similar words cluster together. And when words appear in a sentence, the model uses attention to shift each word's position based on what's around it. No dictionary, no grammar, no rules, no human written definitions. Just billions of sentences turned into math. Next, we'll look at what happens after this step, how the model takes these shifted positions and actually generates the next word. That's the full transformer pipeline, and we will walk through it piece by piece.